Advanced Algebra 1, Topic 9, Section 3. I'm working with quadratic equations a lot. Obviously squared, second degree. So at this point, we're going to learn how to simplify radicals, which can be useful when we're solving these equations. So this is a radical symbol. Some people call it square root because that's where it's most commonly used, is for square roots. But it actually can be any root. For example, I can take the cube root of 64 and get 4, okay? Or the fourth root of 81 is 3. Well, this thing in here, this A, is called the radicand. That's this thing. This symbol, obviously, is the radical symbol. And we call this the index, okay? And if the index is not written, it is understood to be 2. So this is the cube root of 64. This is the fourth root of 81. This is the square root of 25, okay? In order to be in simple radical form, which is what our goal will be, the radicand, this thing under here, can contain no perfect square factor other than 1, no fraction in the radicand, and no radical in the denominator, okay? And so every textbook teaches this differently. Your textbook actually teaches 2 different methods. I'm going to focus on one of those methods, okay? So the way I do this is I go off to the side, I take 63, and I do the prime factorization. So it's not divisible by 2, but it is divisible by 3. It's 3 times 21, and that's 3 times 7. So this is the square root of 3 times 3 times 7. And then here's how, because this is a square root, okay, wherever there are 2 alike, because it's a square root, I take one out and the other one disappears. And then whatever's left has to stay in there. So there's the square root of 63 simplified, 3 square root of 7. And that's all there is to that, okay? So just have some examples here. 44 is 2 times 22, and that's 2 times 11. So 44 is 2 times 2 times 11. So we take one out, the other disappears, and I get 2 times the square root of 11. And 27 is 3 times 9, and that's 3 times 3. And so whatever comes out is going to get multiplied by that 4 because it's already out there. And you'll see as I go, I kind of shorten up the work. Here I did the prime factorization. I don't need to write it out. I can see that there are 2 alike right here. So one's going to come out, one disappears, the other one stays. And so the answer to this is 12 square root 3. 18 is 2 times 40, and that's 2 times 20, and that's 2 times 10, and that's 2 times 5. Okay? So when I go to write this, here are 2 alike, right? One comes out, one disappears. And then here are 2 alike, one comes out, one disappears. And then there is a 5 left, okay? All right, so here's the deal with that exponent on that 4. We do not take the square root of this. We actually, if our index here is 2, we just divide this by whatever the index is. So the square root of x to the 4th is x squared. not because the square root of 4 is 2, but because 4 divided by 2 is 2. Okay? So our overall answer is 4x squared times the square root of 5. Okay? 4 is a perfect square. The square root of 4 is 2. And then x to the 17th is x to the 16th times x. So again, when I take the square root of this, the square root of x to the 16th is x to the 8th. And that other x is going to be left behind, okay, because there's an odd number. So our answer is 10x to the 8th square root x. Okay? Then we have 3 times 2. We can multiply those together. And then I have 5 times 15 is 3 times 5. And then I can combine x to the third and x and get x to the 4th. So now it looks like I can take out a 5, x squared, and the 3 stays. So the answer is 30 x squared square root 3. The whole thing about you can't have a fraction. So let's say we have the fraction 1/3 in there. Okay, can't have a fraction, so we'll separate it. Square root of 1 over the square root of 3, and the square root of 1 is 1. All right. And then there's the rule that you can't have a radical in the denominator. And so what we do is we go through a process that we call rationalize the denominator. And what that means is I multiply that denominator by whatever it is, it's going to make it go away. And what's going to make it go away is if I multiply it by the square root of 3. The square root of 3 times the square root of 3 is 3. The square root of 2 times the square root of 2 is 2. The square root of 5,000 times the square root of 5,000 is 5,000. But if I multiply the bottom by the square root of 3, I have to multiply the top by the square root of 3. Otherwise, I've changed the fraction. So I get the square root of 3 over 3. And that's the answer in simple radical form. There'll be a lot of variations on that, but essentially 1 over the square root of 2, I would multiply top and bottom by the square root of 2 over the square root of 2. And I would get the square root of 2 over 2. If I have the square root of 3 over the square root of 5, I would multiply top and bottom by the square root of 5 over the square root of 5. And I would get the square root of 15 over 5. You can multiply radicals with radicals, and you can multiply numbers with numbers, but you can't multiply or divide a radical with a number. Okay, so I can't reduce this. If I had the square root of 18 over 6, where they're both in the radical, I can reduce that. 18 divided by 6, it would be the square root of 3. Okay. In this section, they also bring into it the Pythagorean theorem. And the Pythagorean theorem, contrary to popular belief, is not a squared plus b squared equals c squared. When we have a right triangle is comprised of what we call a leg, and a hypotenuse. Okay. The reason I don't like a squared plus b squared equals c squared, which your book does use, is because I may not label my triangle ABC. What if I label my triangle XYZ? Now, how do I apply the Pythagorean theorem to that? So what I prefer is that the Pythagorean theorem be leg squared plus leg squared equals the hypotenuse. I just put an in hypotenuse squared. And the hypotenuse is always the longest side of the triangle. The longest side of the triangle is opposite the biggest angle. The right angle is when you have a right triangle, the right angle is the biggest side. So the side that's opposite that right angle is the hypotenuse. Okay? So it says write an expression for C, the hypotenuse, and then find the lengths when x is 15. So a is equal to 2x, so 2x squared plus 6x squared, so there's the two legs, equals, we'll call it c squared, because that's what I have it labeled. The 2 and the x here are getting squared, so that's 4x squared plus 36x squared. And let's see, 4x squared plus 36x squared is 40x squared. And then at this point, I would take the square root of both sides. So C would equal, let's see, 40 is 2 times 20, 2 times 10, 2 times 5. So it looks like a 2 will come out and a 2 will disappear. So I'll have 2. That takes care of those. And then the square root of x squared is x. And what I'll have left is the square root of 10. Okay? Then it said find the side lengths when x is 15. So if x is 15, then A would be 2 times 15, or 30. B would be 6 times 15, or 90. And C would be 2 times 15 is 30, square root 10. And that's in simple radical form, and that's all there is to that.